Hi everyone, this is Jesse here from SkyCiv, and today I'm going to be introducing the Quick Design Bearing Capacity Calculator. We have this tool available in multiple standards. The one I have open here is for the Eurocode 7, but we also have versions available for a factor of safety design approach, which is often what's used in the US, and we have a version available for the Australian standards with both the AS4678 and AS5100 available for users. All these tools have very similar inputs. So the first is a drawing showing us either the plan or the section here in the UI, but that's not going to affect our results at all. We have different analysis methods available to us for different shape foundations and for either drained or undrained conditions. We can update the dimensions of our foundation, and that will be reflected in our drawing. We can update our soil parameters we're going to use in our design. Note that this is all considering that we only have one unit of soil. So if we had multiple units of soil, we might want to be conservative and use what we consider to be the weaker soil, or consider both of those different possible soils in our design and run two checks. We have loading available, including the load adjacent to the foundation. So if we had our bearing capacity failure and the plane of failure looks like this, we can see that this load here is going to be resisting that failure and beneficial for our design. For our loading, we have a table here where we can add multiple different loads. We can add dead loads or live loads. So I can name this as whatever it is. We'll just name it live to keep it general. And we can change our vertical force. We could even have a negative vertical force. So maybe this live load is acting to reduce bearing. And we have different forces like moments about B, moments about the L-axis, horizontal force on the B-axis, and a horizontal force on the L-axis. And as I save this, we can see our design section is going to be updated with these loads being the factored loads rather than the unfactored loads that I've just entered into that table. For our design factors, that's going to come from either Eurocode, British Annex, or some custom annex. And we're going to have to choose our design approach so that we just run this check for this design approach. If we're using design approach 1, we'd have to run two separate checks for combination 1 and combination 2. And finally, we also have a sensitivity analysis. So for this, we can choose a parameter. I'll run the sensitivity analysis for the width of the foundation, and we can choose to create a graph which shows us what happens as we vary from a minimum width of 1 to a maximum width of 8, and how that affects our bearing capacity. We also have additional options, and I can now run this tool. And when I run this, it's just going to take a little while because I've run the sensitivity analysis, so we're doing many different points. But when we do get our results, what we're going to see on the right-hand side is intermediate results used in our calculation, the ultimate bearing capacity that we get, the design bearing capacity that we actually use to compare to our design loads, our sliding resistance and utilization for our stability limit state or our equilibrium limit state, and our overturning stability as well. So all these calculations are shown in this report in the center of the page. We get our inputs that we've just put in on the left summarized at the top of our design report. We then have load combinations, first of all, for our bearing capacity failure, which in the Eurocode is called the geo limit state, or in other standards might be called the strength limit state. And for this, we can see our design loads here that get shown on our graph. As we scroll down, we'll get soil parameters and design soil parameters, effective dimensions, eccentricity checks, the effective unit weight used for our soil, depending on if there was a water table or not present. And then finally, when we get to our bearing capacity, we calculate all our different factors that we need, shape factors, depth factors, and other factors. Those all get summarized, and we get the calculation of our ultimate bearing capacity and our design bearing capacity. The bearing utilization is then shown based on the vertical loads that we've provided. and we can see our bearing capacity here is satisfactory. We also do other checks to make sure that the structure is stable. In Eurocode, this is called the equilibrium limit state. In other standards, this might be called the stability limit state. And in this, we check that the structure is not sliding and the structure is not overturning. Then finally, we can see the results of our sensitivity analysis. In this, on the x-axis, we have our width of our foundation. We can see that as the width of our foundation increases, our bearing capacity also increases. We can see how the different methods compare to each other. And we can see that the allowable bearing capacity ranges, for example, for a 1.5 meter width from around 300 kPa to around 400 kPa. And finally, we have our results summary showing all the results that we had on the right-hand side here by just in our PDF report that we can save and share with others. So that's an overview of this tool. If you have any questions about the bearing capacity calculator, you can message us in the chat. Otherwise, I'd recommend to just play around with this tool, look at the numbers, and see how you can apply this to your own designs in practice. Thank you for watching this video. I hope this helped.